had some interesting speakers this morning. Richard, we've got from ARM, Carsten from Turing Institute, Professor Carsten. Nick, I've been working with Nick quite closely on the working groups in IoTSF, but specifically the S-bombs and D3 and SUIB and some of the other tooling and stuff that we've been working on. And finally, Mike. I worked with Mike for many years. Mike is one of the good guys. In compliance, one of the problems you often face is actually persuading people to be open and transparent about what they're doing. And Mike is, he's been a joy to work with over the years. He has worked with not hundreds, but dozens of AI use cases. So hopefully be bringing some of that experience out today. I'd like to start with you, Richard. You talked about a number of the tools and the technologies that are being incorporated into the ARM architecture. Do you see a renaissance in the way that ARM will be designing its silicon in the future? And do you see you're becoming redundant, maybe because it can be done by an AI?
This very much goes to the sort of theme of the hype of AI making people redundant. I mean, I think it will change what we do. Undoubtedly, within ARM, we've been using machine learning AI techniques to augment what our engineers do. The metaphor that Microsoft uses, actually, I really like. You'll notice that most of Microsoft's AI tools, they use the term Copilot. And I was actually at a talk recently and somebody from Microsoft explained that. This metaphor, the human being remains the pilot. They're setting the general direction. The co-pilot does the boring bits. The co-pilot flies the plane when there's not very much to do in an aircraft. And actually what we're seeing in the way that AI and ML is being used, it is an assistant to make our engineers more productive. We've had studies going on. We've got to be careful because an IP company, you put your IP into a machine, it leaks out. There's been lots of examples of that being talked about. So I've been worried about that. So we're doing it in a controlled manner, but we are very aggressively looking at how we can use this to make our engineers more efficient, to actually get them to concentrate on things that are actually at their pay grade, not things that are below their pay grade, and get the machines to do the things that are below their pay grade. And that actually upskills human beings. That's how technology, in our view, ends up working for people, is it gives people an ability to move their thinking up to a higher level. Now, ultimately, can the machines do all the thinking? Will they be able to create everything? The future is a very long way away. We'll have to see how that plays out. But I'm not worried that this is going to happen anytime soon. I think what you will see is this will be a tool. There's a lot of statistics that have been published about how AI, ML technologies can make engineers more productive, can explore more things, can make computing more efficient. One of the things we've got to do is a large amount of regression. You think about, as you've got continuous integration flows, there's an enormous amount of energy being spent in the universe at the moment, in the world at the moment, essentially doing the same computations again to prove that you haven't broken anything. That's the whole nature of CI. If that can be used efficiently so that actually you've chosen the right workloads to go and find your problems, and so you're not actually regressing against a whole bunch of stuff that's actually of low value. You're choosing the high value things. You can be more energy efficient, you can be better. And so we see it initially, at least, as a tool to make things better rather than replacing engineers.
Tim, if I can just add on to that, I think Anna and Richard, great talks, both of them. And one thing that was implicit in what they were talking about was this idea we're looking at across the research landscape and trying to get it into industries, human-machine teaming. Because we talk about AI as if it's one bit of AI. Anna talked about reinforcement learning, for example, and that's one flavor of AI that's very important. The other that we hear a lot about are large language models and ChatGPT, of course. But all of these things, if we think about it as a team, so just think back to the cultural work of Hofstadter and others and organizations where you do these different kinds of tests to see if you're a completer or a finisher, etc. We all have different skills, and we try to build the best team, and that isn't necessarily all the best players in the squad, but the best team. And we must do the same with the AI that we use. use the AI appropriately. You know, it's interesting that many years ago, machine vision used to be really bad. You know, but it's now at the state where it can recognize things better than a human, for example. So we use the right pieces at the right time. And what we have to do is make sure we integrate people into that and make sure that we're reskilling, upskilling people to do different things as the capabilities go on. I was at the Royal Society. We had an event before the AI Summit. So there was a small round table, so some very distinguished people there and me. But we were talking about the speed. That's one thing that we've got to live with in a sense and try to adapt. But I think one takeaway I took from what Richard was saying and from Anna is human-machine teaming is really important. And I don't think we're quite there yet.
Yes, I think I'd agree. Nick, what are your thoughts on?
I'm probably not best to talk about chip design. I could have a go. I mean,
but AI taking the boring stuff away and freeing humans to do the innovative and interesting, fun work.
The thing is, it's a shifting landscape, isn't it? I would say before like November last year, I count myself as an AI expert. I mean, I've got a degree and a PhD, and I've worked in it for like 30 odd years. I'd say before November, sort of like last year, I wouldn't have believed that the AI systems could do what they're doing now. So the whole concept of teaming is so dynamic because I can't guess what the AI is capable of next. I mean, you can't take your hands off the wheel, so there's got to be a level of symbiosis or oversight. It depends which way you want to go. It's a really difficult one to predict, which makes it both exciting and quite dangerous.
Yes. And Mike, you're a practitioner. You're involved in working on many different AI use cases. I mean, how do you see it? Is this?
Yeah, so I'm very aware. I'm here surrounded by a lot of experts that are very deeply into these topics. I'm trying to apply things in a practical and possibly boring way in order to bring products to market. For me, I mean, I would echo what was just said. A line was definitely crossed, I think, with Gen AI in the recent past. And things have happened far faster than we expected. We're now applying a lot of attention to how people, in an enterprise context, people can interact with generative AI to actually be usefully, safely productive. And I think it's an open question at the moment.
Yes, so thank you. We had the AI Safety Summit last week. The government was fairly clear about its intentions to take this subject very seriously and make the UK a leader in this particular area. I think Michelle, the Secretary of State, Michelle Donelan, in her keynote address, made one comment that she considered cybersecurity a prerequisite for safe AI. Would you see that as being? I mean, the thing that struck me was she didn't say privacy was a prerequisite. So, would you say that cybersecurity was the prerequisite, or maybe are there other prereqs that you would think were important as well for us to have a good posture? So I think you would be a good one.
I'll go first on that. Yeah, I think these principles by design. Yeah, so I'm pleased to be on the executive strategy board of the IoTSF, and the IoTSF did a lot of work in the consumer IoT, the code of practice for the consumer IoT. And I think one of the things that we've got to think about is that was around the security by design. In fact, it was talked about security by default in the very early days, if anyone remembers, but security by design, and it's fundamentally important. But the thing is, there's lots by design we should be doing, and that is around privacy. But the thing is, the privacy, we should understand that one of the reasons why we do these things by design is partially because of compliance with regulation. So there is strong regulation around privacy, which GDPR, of course. For example, that's one piece, I should say. But the thing is, as much as we can do by design, at the beginning is better. It's always better to do these things at the beginning. You know, if anyone's been involved in developing software, when you find it, you know, if you've shipped it, goodness me, it's going to cost you a lot to sort that out. So the more that you can find early on, the better. But the question is, it does cost you something to develop by design. One thing that I've sat on this stage before with somebody called Peter Davies from Thales, and many of you will know he's involved a little bit with IoTSF and certainly with ASIN, which is another part of TechWorks. What we work on is resilience by design, so really making things resilient. And one thing about resilience is if you can get it to operate in the face of adversaries, when adversaries are around, then actually you're talking about operational. It becomes not a cost. Security by design is seen as a cost, right? Oh my goodness, you know, I'm spending loads of money to secure something, but it's only if it will go wrong, you know, so it's seen as a risk thing. So it's always difficult to argue. If you say I'm building a system that's more resilient, then that helps because you say, well, there's unexpected things that can happen because of an adversary or for other reasons, but we're going to make sure that it's really operational. Then people say, right, that's a value add. That's a quality thing rather than this negative thing of security. So I think resilience is important. So consider all the things that can go wrong. Security is sometimes thought of just as protection, and it's much more than protection because I remember many years ago, Kieran Martin, when he was a chief exec of NCSC, saying, it's not when you will be, if you will be breached, it's when. You know, and there's other people who say that there are those that know that they're breached and those that don't, you know, but basically everyone's breached. So I think it's really important to look at how you react. So I think that is more important than a very narrow cybersecurity.
Yes, I think that's very true. I mean, historically, I mean, most of the system's cost will be in the live phase, in the operational phase. So if you can reduce your operational cost and maintenance cost early on by shifting left, that it's not a cost, as you say, Carsten, it's actually an investment that will actually save you money in the long term. Nick, I know that this is something you're very passionate about, the value of doing things the right way.
Yeah, I mean, absolutely, there is huge value in sort of like raising the baseline. And there's certain sort of like key initiatives, and I mean like the Morello type stuff, memory safety stuff, software management stuff, update stuff, which is all good, healthy hygiene factor. But I think we also sort of like need to be careful. I mean, sort of like software, sort of secure software processes have been around for a while. But they come from a very, very different place. Usually they're trying to produce very sort of small, tight, deterministic systems that are very predictable. And that's how we get the safety. With the AI stuff, it's a completely different game. You've got a complex piece of software made of lots of modules being driven by 70 billion parameters. You do not have deterministic behavior. You can't possibly anticipate everything that it's going to do. And I think that sort of what Carsten was intimating, I think it needs a little bit of a sort of a phase shift in the way we think about things. We need to think sort of organic resilient systems, tight feedback loops, methods of being able to, you know, do stuff, spot it's wrong, counterclaim it, correct it quickly and fast, because there's no assurances there are possible. And I think it touches on some of the things that we're trying to bring over from the work we've done on many security. I mean, one of the biggest problems I see with AI at the moment is versioning. If I want to say anything about an AI system, I need to be able to point at it, and I can't, because that point is a complex piece of software, which is probably predicated by something like an SBOM, driven by, like, you know, 70 billion parameters, which has been derived from, you know, data in the terabytes. That's a lot of moving parts. There's a lot of dimensions. But if I want to be able to say any qualified thing about any facet of AI safety, the first thing I need to be able to do is be able to point to that version, such that I know if I make another statement in the future, it's the same thing. And that is, I think, one of the practical things we can look at.
But it's not just the system, it's also actually the AI system and the platform it's running on, because actually everything, the whole thing is layered upon it.
And I'll say one extra thing, it's the context and application that you're putting it to as well. There's three major dimensions, yeah, absolutely agree.
Yes, so sort of a defence in depth approach. But I think the thing is also you've got moving parts in terms of the actual data, and the training sets will evolve with time as well. So if you have a medical system, a diagnostic system, the training data you use will evolve with time as you get more data and more results, etc. So, Mike, as a practitioner...
Well, I think what was just said illustrates the challenge, actually, of the AI as a term is a very broad church. And particularly in IoT, you've got the extremes. You have the single scenario use cases that were mentioned earlier on of recognizing a single picture or number plate recognition. And at the other end, you've got the most sophisticated ones in areas like automotive. So trying to take a one-size-fits-all approach to managing the risk, regulating those things is incredibly difficult, and probably stretches that potential to its limit, I would have said. So I think that will be one of the challenges of the processes that we apply and the regulation we apply is how we actually define AI, how we define when they apply, what's applied to what.
Yes, I mean, Carsten, you mentioned the cost of compliance. I think, Mike, it's a very real issue. And if an organisation such as yours, Vodafone with deep pockets, struggles to be able to afford all the different systems and processes and checks and balances, my question really coming back, I think probably you, Carsten, would be, what place is it for the SMEs and SOHOs and Anna referenced mid-tiers? These technologies are available, but they're very expensive.
Yeah, I think it's a really good point, Tim, and let's be absolutely clear that the SME kind of small to medium enterprise is really important in this space. So one area where I work where there's a lot of AI used is financial systems. So I do some work with some of the largest banks in the world, and actually they are quite reserved in how they use AI. And why is that? Well, they've got a large history and they're very worried and they've got shareholders and prices. Whereas the fintechs have been really embracing AI. So this is one example where, the importance is there. And that's true, you look when Google first started, a couple of guys over at Stanford, doing some stuff. It's really important, and it's a challenge, right? Because I think Anna mentioned as well, we're in a global world. There's different countries contributing to AI, and it's important that they are acting as well as possible. So first of all, there's regulation, and in the UK, I'm proud to work with a number of our regulators, and I think the regulatory space in the UK is really good. I've got to say, I think it does genuinely want to foster innovation. It needs to protect certain, parts of society or industry, but what it wants to do is really foster innovation and have conversations. And it's important that SMEs have a voice at those conversations, I've got to say. But from what I see, that there is that willingness. So that regulation is something that you then need to comply with. So there's compliance, but there's also things like at the Turing Institute, there's the AI Standards Hub, which is giving workbooks out, just like a double gatefold kind of workbooks for you to question about the ethics and governance of your AI, which I think is useful. So that's useful sort of process tooling. And I think SMEs can use that. I think they can use good practice. They can use standards, So regulation is something that's forced on you in compliance, but standards are there to have some kind of leveling across the field. I think there are increasingly some tools that can support. We're lucky. Open source is very, very big. So I was speaking to John Crowcroft, who's researcher at large at the Turing and one of my co-investigators on a large project. And there's more open source than you realise. A lot of Microsoft, what they've developed is actually open source that they build upon. So I think there are tools there that can help. We have to make sure that they are effective, and academics are working often, but we understand that ours are not often production-based. But the open source community where you're offering services on top of a product is quite rich, and I think those kind of things can help that important market of small office, home office SMEs.
And Nick, so democratizing the availability of tooling and techniques, again.
It's challenging.
Yes.
At the moment, certainly, you have to divvy up what you mean by AI systems, but a lot of people are still talking about the foundational systems at the moment. At the moment, it's a two-horse race, and unfortunately, in the UK, we're in the second tier. The compute power, the access to data, the increasingly what's going to be a bit of the problem, the commercial leverage to negotiate rights to the access to the data to train from. Unless you can deal with those fundamental issues, you won't actually be able to build a foundational model, and then the foundational model will obviously gravitate towards those. So what can you do? I mean, you can look at building up resources, like the compute resources and the data access resources to build your own. And I think you can look to creating a licensing ecosystem, or possibly even a legislative framework that doesn't. That levels the playing field, because there is the legislative interventions, but before them there's the classic licenses and terms of use that people sign in terms of contracts, and at the moment that's all quite fuzzy and quite nasty. I mean, I think a lot of the AI hackers out there haven't read the terms and conditions of what they're doing, because if they'd read them they wouldn't be doing it, and I think a lot of work needs to be done to make that sustainable. Otherwise, we're in danger of seeding a load of small companies that will just die.
Yes, sort of an intractable problem. But as I said, the work that IoTSF has been doing historically on SBOMs and declarative mechanisms to describe how the systems are working and operating so that they can be automated in terms of the monitoring and management.
So on the cyber side of things, which is like probably where we spend most of our time. Historically in the Managed Good project, we've done a lot of work in terms of putting in place the innovative cybersecurity infrastructure to do what I said, to point at a system and make a claim about a system. And there's two main sort of dimensions to that. There's the thing itself, which increasingly SBOM or SBOM derivatives are sort of like being used to do, and I think that has a huge role to play. But then there's the other thing, which is making claims. And the knotty thing about sort of like trust is it's not binary. It's not a yes/no answer, and it's very subjective. So one of the big things that we've spent a lot of time doing in the Managed Good is build sort of the claim infrastructure that will support one person making a claim about a thing, and then somebody else making a counterclaim about a thing, or an auditor or an accreditor, but in that full infrastructure. And in terms of, it's very early days, but certainly in the summer we ran two sort of like workshops, or a workshop and a webinar where we brought together a lot of sort of like industry parties to see what we can do. And there was a sort of soft consensus moving towards this thing we called the TIBOM, the Trusted AI Bill of Materials. And it's built of those various components. It's built of the bit that I mentioned earlier, the ability to version and label the software system that you're running, but then also to version and label the data that you're training it on, and then the configuration data that it's running off. And I think, as Richard mentioned earlier, two other dimensions which are key is the underlying hardware and software system it's running on, but also the hardware and software system it was trained on, because that's part of the tool chain. And it's a big, sort of like quite ambitious project, but I do think it's touching on some really important problems that are sort of that are foundational and are going to be required to even sort of start touching on the more complicated things above it.
So really, Nick, what you're saying is by being transparent about your componentry, whether that's the software components, the open source, or whether it's the AI components, its data, etc., that is the way you see it for moving towards strong compliance.
Transparency and provenance, and I think there's one extra little caveat, which is it doesn't have to necessarily be fully open. This is a nice thing that you can do with crypto claims, is you can make a claim about something without actually having to disclose the underlying data. But yes, absolutely. Yes.
So transparent, but you don't have to be transparent with everyone.
Exactly.
It's you have to have that internal knowledge about the system. So Mike, I know that you've been extremely transparent about the AI work that you do within the organisation. Have you got anything to add to this approach to moving forward by being transparent in terms of what you're doing and what you're working with?
No, it chimes with the thinking. I mean, to me, what it illustrates is that trust by design, which is the name of the process that we follow, which clearly is in line with what I'm hearing here, is a living thing. It continues to evolve. It involves a diverse range of subject matter experts from different areas. and it has to, because the range of things we have to track here are a very fragmented landscape across industries, across geographies, needs that breadth of knowledge. And it's got to tackle an increasing pace of change. So, I think this is just an illustration of the need for that process to continue to evolve, from my point of view.
Yes. One last point here, Richard.
We're close to time. Just to pick up on the whole bill of materials thing and understanding the systems, one of the things that isn't talked about enough, in our opinion, is actually people forget that chips these days, modern SoCs, are in themselves an amalgam of IP from lots of different places. And increasingly, people are talking about, I'll integrate an accelerator for ML-type purposes. Where are people getting that from? Who's asking the questions? Because actually, for example, there are plenty of Chinese companies producing those IP. Do you want to trust that? You want to ask a lot of these questions about actually the provenance of the entire system. Systems are incredibly complicated. Modern processors actually are an amalgamation of lots of different blocks in their own right, and there is not enough conversation going on about the provenance, or even of the hardware underneath it. We could be very careful about that as well.
Great. Well, I think that's something you can do now. I mean, this is the IoTSF conference. As IoT practitioners, transparency is something that we can all sort of work towards. So on that note, I think we got 1 minute. 1 minute. Have we got any questions for the panel? Yes. Oh, yes.
So just a quick question. So we've got the Cyber Resilience Act going through Europe at the moment. One of the aspects there is a possibility that open source software developers will have legal liability on their software. Do you think that could impact the flow of open source projects moving forward?
Yes.
You put lawyers anywhere near a process, it's going to impact it, isn't it? I mean, simple as that.
I think there's been a lot of discussion about this particular topic and open source, and it's very emotive discussions. But what I'm hearing is that it's the people who use that technology who will be legally liable. The fact that somebody produces some code and makes it available to the world, you can't hold them culpable for that, and you can't even police it because they may not even be in your area. So it's actually going to be using open source software and the users of it that will be potentially criminally liable if it goes wrong. And in order to be able to address that insure against that problem, then I'll refer you back to Nick in terms of SBOMs. You need to know what open source software is in your product. There was the Log4j hack about 2-3 years ago. How many people have still got unpatched Log4j components? We don't know, because Log4j, it was actually used in lots and lots of different products, and many of those products haven't been patched. So, your inventory of componentry is critical to be able to understand what your vulnerability position is, but also in terms of being able to do something about it. But at the end of the day, liability will be with the organization that deploys and makes commercial use out of that product, not the open source developers. I think there's an opportunity for open source developers here. Again, sort of Carsten, I mean, in terms of if somebody does develop an OSS product, there's a monetization option to support that product and charge organizations. It might be charging the Turing Institute to actually oversee and make it available. But do you see an opportunity? I think the problem has been much talked about, but I think there's an opportunity here in terms of supporting the OSS community.
Well, the whole point is that, as I mentioned about open source, is in lots of things that we see as common products at the moment, and that is a wide ecosystem. We need to make sure that anything like this CRA really delivers what it's supposed to do without having unintended consequences, which might slow down some things. But I think there was initially this idea to go after developers. Crazy, you said the word. Can't police it properly, and what are you going to do? Sue them, put them in prison? It isn't going to work. So you have to look, and that support system, I work with a very large piece of digital public infrastructure and digital public goods, where it's actually integrators that take on a lot of that. So you sort of ATOS type ventures that do that and take that responsibility.
So do you think government should be providing a sort of sanitized OSS set of libraries, or organizations that should be...
How and at what cost? No, I don't think that's possible, to be honest.
It's too expensive for everybody to do it individually. Would it not be...
but that's why it's an ecosystem, right? And you've got to understand, if you use something that you haven't tested fully, or you're not confident, or you're not sure of the provenance of, then you have to be taking that risk if you're taking some monetization out of it. I think that is fair.
Well, so Richard,
just to make the point, not just open source software, same applies to open source hardware. If you're going to use something of unknown provenance, the risks have to lie with you.
So on that last very interesting topic of OSS and its role in AI, and bugs and defects and vulnerabilities, I think we have time. We've got to go for our break now. John, am I right? So thank you very much to the panel for your